Our next presenter is Seth Meldon. He presented in 4 or 5 last decision camps, and as a representative of one decision intelligence platform vendor, Progress Corticon, and he always has this perspective that coming from the real world use of the system, and it's apparently Corticon added Gen AI supporters or copilot to their product, and they have experience, and Seth decided to make a controversial title. If you, I read it as he is replacing human from the rule modeling or decision modeling tool by AI. And that's quite a statement, and let's listen to them.
Thanks, Jacob. That's a provocative opposite reading of where I'm going with my title, in fact, as I'm going to get into.
Okay.
So I wanted to take the time today. I'm going to show, as Jacob mentioned, Corticon's, we've been doing a lot of stuff in Gen AI, but not so much in the philosophy of human in the loop, because for the same reason that in this space with this type of software, must be kind of a certain character of a decision in order to use what is historically just a rules engine as a software. And usually that is quite an overlap with these types of tooling that you would be most comfortable being a black box or not. So here we're going to use AI as the means to be in the loop while the human's doing the work. The things that we're using rules for to express are typically the things that we need to be most able to explain why a decision was made at a given point in time. Obviously, a rules engine has been doing that as a concept for decades now, but the degree to which that paradigm lends itself to better leverage AI in order to not just understand why a decision was made, but also ensure that the implementation phase of the actual rules is also AI empowered, but not deferred to AI. To start us off, though, I'll talk about something a little bit more abstract, or I guess the opposite is something much less abstract, which is just the concept of data gravity and the paradigm of just we're at a point where obviously we've heard a lot about the overinvestment in AI tooling without any payoff thus yet. And there's also a bit of a cliche nowadays of just having too much data after having accumulated it for the sake of accumulating it and deploying it in cases like this. So there was a report just 1 month ago. I pulled it in from a Deloitte report about the changes in where data centers are being organized as far as the organization's operational costs. Just because if we're going to be exposing and loosey-goosey with how much data we're going to be training this or that model upon, agentically or otherwise, it's still a lot more data than it needs oftentimes. And so the query, just the latency and the cost of transmitting that data, considering you might not always be entirely sure you're co-locating the data that's relevant with where that actual compute, where the complexity is, it creates much more of a sprawl than is really necessary. And so irrespective of where, this is kind of taking the stance of the direction, I'm not going as far as the remediation being, you should move stuff on-prem that should be on-prem and cloud that not. Instead, I'm going to talk more about bringing the compute to where the data lives, focus more on the point of working through data gravity to co-locate not just the complex data, but also the explanation for why data changes over time, as might be reported from a rules engine. So there's obviously like an inherent usefulness in a mature rule expression of complex logic as business rules for exhaustive reasons that I won't go into. But the degree to which the implementation of very complex rules can never rely upon or doesn't need to ever rely upon supplementary code that strays from a more deterministic and constrained schema of how we're defining rules, makes it that much easier to ensure that we're able to express rules as we expect, but also to query which rules produce which aspects of the change of the data as they're executed. So I'll stop talking abstract and more based upon the nice thing about auto insurance policies is there's quite a lot, at least in this very niche group, this will be useful, is the degree to which you can get hundreds of pages of your local car insurance policy manual, because a lot of that's regulated. It's also regulated at a very granular level, state by state. So many of these characterizations are things that sometimes a state will allow or will not allow you as a car insurer to even evaluate. Like in this state versus that, you might not be able to grade riskiness based upon gender, upon student, upon age. These are all at a state level. So that's just an introduction to even what you can judge based off of. But the rules themselves start to get impressive as far as what is available. And so this is a local to me in Massachusetts, Arbella. So current 2025, all of these rules. This is just a representative snapshot for a representative use case of what I want to talk about, using just kind of a domain, non-specific, familiar enough to everybody type of use case. So I'm going to talk through how the components that have been incorporated into Corticon have melded themselves into and made much easier what was already there, but also exploited a lot of what historically my answer as a sales engineer for Corticon has been, yeah, you can totally do that if you were to do this, this, and this after Corticon's done its thing, versus be able to demonstrate with kind of the reliability of the type of output you might get from a deterministic system, develop more tooling to actually inquire upon and analyze what changes to the rules might make, not just conceptually as far as a bunch of test data, but also upon the data that you already have accrued, and in this case, policies that we made decisions upon in the past. So in the typical, always same starting point as usual, let's just take a payload upon which we might want to define some rules. I'll show some of those rules in a moment, but just to make sure we're defined to kind of a constrained schema from which we'll be building our rules. This is the root point at which we might define the schema of the type of data that will be evaluated by our LLM when we go about to actually inquire why decisions were made at a later point. We're much more structured, so the degree to which we could be operating upon structured data makes it vastly easier to leverage any sort of retrieval augmented generation, but also just understand at a specific query level of why a decision was made at a point in time. So you might also want to take the schema that is already defined for a fairly common and standardized area, such as auto insurance. Again, there's standards as far as the types of laws and the structure of the data about how you're adhering to this or that regulation for coverage. Sorry, I didn't mean to restart that, but this will just, let's check as far as, are we adhering with the vocabulary in Corticon speak, the data model we're building here? To what extent does this, as it's been generated either by hand or automatically, to what extent does it conform to a given standard? And so what we're going to be doing is incorporating all throughout the rule development, the rule implementation here, a AI in the loop. Humans not riding shotgun here, AI is. So we're going to see things like just checking read-only wise based upon the query saying, you have a question coming in from somebody within Corticon Studio that has currently on their focus of the screen a rule vocabulary. The contents of that file that they're inquiring about that's currently open is this as a JSON representation. And based upon that system prompt, then the AI generated response is going to combine all of that background information with the actual user query in order to incorporate all of that information into a more conversational response. Now, that's just for the sake of modeling the rules, which is, of modeling the data, which is a one-time thing, and then you tweak it very little over time, typically in these situations. So what we're
Uh,
likewise going to be.
Seth, can I just want to clarify? It's a very interesting question. So what you exactly gave to AI assistant as an input and to get this JSON already was there, or just plain English description? Or standard like Accord? What was input?
So this is a bad example to answer that question with, because it's just so happens that I pasted JSON directly from a theoretical JSON schema that I want to validate against. Irrespective of me having sent in my query JSON itself, what's getting sent to the AI assistant is the context of a user being in Corticon, the user having a rule vocabulary document in focus, and the contents of that vocabulary on top of whatever that query was. That's all represented in a standardized JSON schema that's defined at the level of AI as far as what to expect. It just so happened that the query itself also contained JSON here.
Okay, share your screen, please.
Oh, did I stop?
You're not sharing screen. No? I don't see your screen.
Oh, I
Okay,
don't know.
good.
Sorry. What have I been sharing at all?
Yes, now, no, you're sharing.
Okay, I'm not sure why that's not
everything good now.
Okay, great.
Keep going.
Stuff of nightmares there. All right. All right, so let's proceed. Now let's actually use that. Now at least we're coloring inside the lines as far as the rule vocabulary we're working with and defining rules from. So moving on, maybe we want to just, at least from the sake of a very complex rule. So we're going to show how we build out these rules first, but likewise, we might be just onboarding as a new user to Corticon. Corticon is a long time. People on this call have known about Corticon longer than I have, for sure. So we likewise have a lot of customers that have long since retired, systems integrators that implemented projects in the least understandable, explainable, well-documented way possible. And so this has been very useful for the sake of just, okay, explain what's even going on in this example of a fairly complex rule sheet upon which we're defining all of these different surcharges and evaluating whether or not to apply a surcharge based upon a number of incidents. So in these just suggestions, those are canned prompts that will be sent along with what I mentioned before as far as the background data. So here it's just inferring based upon it knowing kind of the baseline paradigm of how rules are created within a rule sheet of any number of conditions, produce any number of actions, fields, values, and building out just the documentation for us. So this is just from the standpoint of getting to something that's already built out and even understanding it. So likewise, we might, when we're doing stuff manually, just as far as the types of constraints that we're going to have in a rule vocabulary, we might have, say, a enumerated list of potential data types. So this will likewise be, if you think back to that JSON schema, maybe having various enumerations for discount types. In this case, this is just a classic Corticon functionality of only having rendering discount.category based upon that enumerated list. But that also will be built into the query if we ask instead for the AI to do it. So let's do the same thing here, but or we'll see the implementation of it in just a moment. I wanted to split out the kind of read-only stuff from the writing, which is a bit more interesting. But by virtue of also having a lot of more lazy implementations in the past, some of the ways that you might have documented your rules over the course of them might not be there. So the way that you can optionally provide more of a baseline response in plain language along with a rule having fired is to just have a rule statement, which will be sent back as in a similar vernacular as a rule message at runtime. So we can just copy the natural language descriptions, and these will be sent back at runtime with whatever values have been produced if a given rule fires, and only if a rule fires. We're going to see how that's one of two kind of meta information upon which we can document rules, which are all going to be useful for analyzing the performance and kind of population level of the decision outcomes later on.
Sorry, I will interrupt you again because it's a very interesting topic and most of us doing the same. Why do you need generative AI to generate this text if you already know a rule? It's very easy to generate this straightforward convert tabular representation to plain English. It's just extremely straightforward. You don't need a large language model to do it.
Yeah, it's a debate, and I mean, it's also to what extent do I want to answer your question in a way that suggests I'm automating away my own job? So I think honestly, a lot of the read-only stuff is useful, but more so what I'm keen on exploiting is the degree to which we can confirm conformity to much more complex things, both as far as rules changing from point to point over time and needing to ensure that you've isolated out every point at which those rules have changed. So having more and more capability to use more of a generative, a RAG-centered approach where we can have a more informed AI assistant to see what we're implementing and understand the expected output of data that Corticon might produce, and compare that once more with the more structured interpretation of a policy document. So that'll get much more useful when we kind of integrate the textual representation of the rules as they're initially authored and publicized, and how we're operationalizing them here, ultimately into code from these rules. So just a baseline of, let's implement that same set of basic rules here. We can see how Corticon will be able to, again, conform to that standard of expected, the expected syntax. If this was lowercase good student, then that would be flagging an error. So Corticon can take that into account too. Now, let's be a bit more interesting and just copy the actual contents of, say, this hypothetical insurance policy. And so here, if I just paste the initial sets of rules that I need to implement, again, it's going to conform exclusively to the data model that we've constrained it to use, because we're constrained to use what we document in this rule vocabulary here. So here I am asking for each of those rules to be generated, and it will take, I can put in parentheses here that it might take a minute or two, because I didn't edit these videos at all. So it's currently merely waiting on an OpenAI model to respond. So for that sake, I can boost it along. And it will show the implementation, again, conforming to those enumerated lists of potential coverage types. Then I can continue on to, again, be the overseer. This is a nice servile performance by this AI assistant who is only doing things at my behest as I explicitly define. Now, if I go something a bit more complex, maybe we go into a whole set of implementations of some of these discount rules. So this time I copy it, ask for the implementation of, or check whether or not the specific rules that have just been created are indeed within the scope of all of the rules that might have been created thus far. I can isolate. This is one of a lot of ways we might boil down where a specific aspect of logic is being configured. But this can likewise, just in terms of even before generating what we call a rule flow into the runtime decision service, it will tell me, just based upon what it's been sent, where specifically a given output might have been produced, and what specific rule within it that rule triggered. Now, so just let's talk more about one other thing. I mentioned this is one of two things that gets sent back as far as the explanation of why a rule fires the way it did, the data changed the way it did at a given point in time. So let's say I'm going to continue on this paradigm with the same use case. I have these two different test cases that already, perhaps I'm migrating to a new system, or I'm just generating test cases based upon this predefined standard using a Mockaroo tool or the like. Maybe I want to just generate some test cases, copy and paste those inputs that I know to conform to that spec into what I also know to conform to that spec in this rule vocabulary. And so we'll see the actual changes made to the output data the impact of the actual rules changing the data itself, those rule statements being translated into messages, but likewise surface the explicit changes just at a unit level of every last change that made over the course of all of these rules executing, seeing kind of the data flow and the data lineage just within the course of an execution. So copy and paste this into my rule output. Perhaps I also have expected fields that I want to compare whatever the output is generated as. I might want to compare that with whatever the output is and then isolate out where there might be distinctions between them. So if I now go ahead, and that was very quick. So if I now go ahead and run this, then we can see first, I can see in bold all the change data. If it's in red, I can see that there's something specific within the output that does not align with what the expected value were. I have my just plain language statements, which are nice, but also you're relying upon, again, the good-heartedness of the rule modeler at the given point in time to have implemented the specific aspects of the output we're looking at. So there's no requirement that you document each and every rule such that you know the explanation for each and every rule that fires. But that doesn't mean we can't also interrogate what the evolution of this data was just by exposing this rule trace view of every last thing that was triggered over the course of, say, if I want to evaluate why a given premium does not align with my expected premium. Where'd you go? There we go. Okay, sorry. Now we can see just, again, the explanations, but also in that rule trace view, we can see the sequence of events of all of these 10 different policies, the input, every last thing that happened over the course of the execution of this rule flow prior to me generating it into a decision service. So what I did here was I just changed one of the output values for the expected to be $10 more. And if I go into this rule trace view, I can say, click on the specific field that's mismatching. It'll automatically bring me to the specific rule that was the 3,920th thing that happened when I ran that test, the nature of the change, upon which specific aspect of the JSON payload that change was made, what it looked like before and what it is now. And if this is the particular one that doesn't jive with what my expected output was, I can double click it. It'll take me to that specific rule. So this is all before we get to actually doing anything with the generated decision service. But all of this information is available both within Corticon Studio, but also when we do send back the output of the decision service. So just at a more structural level, the JSON that might be coming out after executing a decision, the structure of the format is going to have three main components: just the actual data, the stuff that we might care more about, all the various different new coverage premiums, and understanding where, if there's a given type of safety element, then we might have a discount, again, judging for good student discounts, etc. So we have just the output data itself, but we likewise have the log of those plain language statements. We're not bound to include all of this and the next type of data into our actual output. But here I'm able to see that I have all of the explanations in plain language, but I'm not bound to just that. So beyond that, I want to note that obviously this is all very standardized. So anything that was even remotely unstructured from the initial implementation or the initial policy document that were handed off, it's going to be not the same problem at all as far as what comes out. We can expect the exact structure of the data from the output messages themselves, and also the trace, what we call the decision trace log, with all of the various changes over time. So it can all be exposed and expected as far as the type of data and the formatting of where to look for what, in order to understand at a root level every last change that might have changed a input decision to an output. We can isolate that and share that with an LLM to train it with as well. So in this case, I'm going to just go ahead and generate the rules into a JavaScript bundle from which I can now, let's start to develop some more realistic tests as far as, or not tests, but so much as understanding how we might leverage all of those different three ways to consider that output data in order to perform more kind of analytics and surface more interesting stuff at runtime. So in this case, I'm using, just because I have it in-house at my company, my employer, which sells more than just Corticon, I'm using a NoSQL database called MarkLogic that is under the Progress hood. MarkLogic is a multi-model database that can act as vectors, but also is very useful and kind of born and bred for search applications. So by training and structuring unstructured data from policy documents, kind of extracting the more standardized blocks of text and this and that logic from those blocks of text into an expected type of format, we're likewise going to be able to incorporate a lot more originally unstructured stuff into a type of tool that is night and day as far as accepting anything unstructured. That is not the world in which Corticon lives. That rule vocabulary is the entire world of data upon which it might be able to evaluate. Again, we're constraining explicitly as the humans any type of change that's being made from the get-go as far as creating that rule vocabulary and ensuring you're only going to be adhering to a given standard. So by virtue of really having every last bit of the implementation of the rules, this is a breeze through a bit of the actual rules themselves that were implemented along the way here, but suffice to say they could be very complex. So exposing not just the order of events, but just outsourcing the more tedious work of things that would be a good developer practice that can't be relied upon, whether using a rules engine or not, as far as commenting and segmenting out our code in more understandable ways, both in order to find places where we've not done that, as well as to do that tedious work of document this and that for me. The AI, as far as the rule modeling, is extremely useful at surfacing that information, generating it for us so that we can also leverage it at the front end, because that makes it that much more explainable when we're explaining why a decision was made at a given point in time. So here, again, I'm just going to use Corticon.js was in that studio environment was just where I generated all those rules. Now I'm going to use those were 10 different test cases. Let's have maybe a few different test case documents, each of pretty considerable length there. I'll have about 100 kilobytes each for the input and incorporate into the output all of the policy explanation as well as the order of events that we're doing. In order to then interrogate it, ultimately we'll be literally interrogating that by exposing that data to a conversational interface. But there's other ways that we might use it as well. So just for the sake of building out the front end in order to kind of query this data, there's very little that needs to, like the low code, vibe coding types of tools out there. If you're able to reliably produce the structure of a type of output, which Corticon is going to do, again, it's living only in the world of structured data. It's vastly easier to have the AI there in order to query, because it is going to never really stray. If we're using a RAG-oriented approach with a rules engine output and exclusively leveraging the outputs that we're seeing here in conjunction with the policies that we're automating themselves, then it's not going to have any degree of hallucination available to it as far as the data from which we're making decisions, or excuse me, from which we're producing these responses. I'm operating only upon the outputs as we saw in a different format prior to deployment, the logs of the rule sheets and the explanations of the rules that have fired along the way, correlating those to the specific rules. And if I really need to do some in-depth analysis, I can likewise go into the specific, presumably this would be more useful for an internal system, in order to go and ask for a specific change to a specific rule from the business as they actually encounter an explicitly malperforming rule doing something that is not in line with a given policy. So if I continue on now, I can likewise surface the same sort of queries where we're not merely going to look at, say, I'll show, I want to show one other node here, which is, actually, never mind, it doesn't show it there. So let's skip to the chatbot here, where I'm going to add OpenAI to the mix based just in my environmental variables. For the front end here, I added the OpenAI key. That's being leveraged in conjunction with the data model that's being parsed out by MarkLogic. So while I have gigabytes now of these mock output data, it's chunked up and created into a more schematic view of where we can find what information and how we might join the explanation for this or that rule with this or that policy, as well as with the broader how do all of those rules affect all of the policies at a root level and at a population level. So we can expose different types of views, but in the same way that we're not using just potentially straying from baseline world data, or from baseline data that we have internally with this retrieval augmented generation approach, where we are straying outside the stateless model of Corticon, where we are persisting data, not with Corticon, but persisting all that can be persisted from a decision service having executed. We can explain and kind of develop the baseline queries for where to find the types of data, as well as parse it out with labeling to make it as findable as possible. So this is just one of the first runs. Sometimes it's fast, sometimes it's not. It's the nature of the beast, but these are all, this is just one of the potential widgets that can be built should one desire, as far as querying that data based upon what's been outputted. That one just ran. So I do have all of these elements running as well. So I figured this is all, it's always a good idea on a recorded session group to do any live demos. But everything that I'm showing the screenshots from, I wanted to show that's not just demoware. These are screenshots from recent weeks of developing this. There's a few things I didn't show as well, such as just talking about how we might do more population level things. Again, maybe I want to go look at the state-by-state breakdown over kind of a widget that can illustrate the different aspects of those rules. So we can surface a lot of stuff, but I just wanted to leave time to have more open discussion at this point while I kind of talk to your head off about all the different ways we might surface and make use of the output data from a decision service here.
Probably it would be good if you show us chatbot example.
All right.
We still have time. Okay, it's not necessary. It's up to you.
It seems the window closed in the background. So if there's any other questions while I get myself in order, happy to answer them as well.
Okay, thank you very much. And do we have questions?
All right, I'll show a bit more interest. About that. All right, so we can start to look at both on the back level the types of data that I'm able to evaluate. So in my setup as far as the decision service within MarkLogic, here I'm going to see I have various different policy input documents just to illustrate more of the final potential inputs, outputs. We're evaluating at an elemental level of across all these different inputs, the types of devices that might be on board. So this is kind of the intermediate layer where we can store and persist the data, create views from it, but then inform in the same way that we're able to inform the backend. I can go find, say, let's look for when did, and based on what did this particular application get evaluated. I can see how I'm sorting into collections, both the inputs and the output documents. So if we inquire about this particular one, this is the type of data that, again, it's always going to conform to a recurring schema. So we can just define and leverage semantic models in order to understand interrelations between these terms and understand when one is present, when one never will be, in order to emphasize that if there's an explanation for a rule having fired within these messages, then we can more easily correlate it to or tell a front end to actually interact with it in a particular way. So while this is just loading up here, so let's take a look first again at the root level of a search of a given policy. Assuming I am running in the background. Oh, there we go. Okay. No, I want a different one. I want this one. So you can see how the data is chunked up. That second query was much quicker after it ran that initial one. So I can surface data about the input data that changes just as it received. If we're defining, say, against a particular vehicle, this Mitsubishi Mirage, we can isolate out where specifically a given aspect of the change was made. But moreover, maybe we want to understand what specific rules might have contributed to that particular net premium having been decided. So let's see if there's a more egregious amount of money that perhaps we're going to need to inquire for why a decision was assigned to have a particular premium. So let's ask about oh, sorry, I'm in the policy search. I'm not in the chat bot. This will be a better place to actually ask a chat question. So we're sending in the background to OpenAI, again, the same sort of representation that we were doing when we were modeling the rules. But this time we can surface what specific rules fired, the nature of the changes. And this is going to incorporate both or all of the different ways in which the output document has documented the decision as it was made over the course of time. So this is just at a unit level, but then we can likewise say maybe evaluate across all the different states. This is just some widget to show using.
You do it too quickly. I'm sorry. It was very interesting what you just demonstrated. So you actually, your model or AI model actually analyzed your log file, or it went to source rules and understood the semantics?
Yes, both. So in that little query console, when I just dug up this particular output payload, this is showing, so I'm exposing to it the input document. I don't even necessarily need that input document because I'm incorporating an explanation and documentation of the nature of every change along the way. So in this payload array, I have all of the actual output data, just those actions. That can be traced back to the particular rule explanations, the first aspect of that rule test demo that I showed a moment ago, and also telling it where it can find information about the changes made in those execution metrics. So individual field value changes, where and when, upon what specific entity amongst all of the entities that change was made, and what it looked like
I'm
before
sorry,
versus now.
I just really want to understand. So who produces rule sheet name field? Your program or LLM?
Corticon.
Corticon produce. So it's
Yes.
a regular, it's your regular system produced. What
Yes.
exactly, so LLM just converted this to user-friendly format?
So, correct. The way that I have set up this database here is when a new document is received in this policy input, it automatically is going to invoke that decision service, that it will persist and create that new output document leveraging all of these output fields, which obviously perhaps it's you're not going to want this in production as far as all of the runtime.
Okay, very good. Seth, just question here. We're all interested in the question, or maybe you do have this example when LLM-based tool actually produces new logic Right now, it can use for pre-processing, it can use nicely for post-processing, for more friendly representation. But do you have an example when logic, business logic is produced by LLM just using several your JSON files or general information like Accord or from large language model information, something like where you really do you have example producing business logic or and without hallucinations or not?
By as in like more of the example. So we have I showed kind of the generation of the rules as the screenshots. Are you talking on the rule implementation side or on the side with interrogating the output data? Because
Anything what you can show because it's something what in interest for all of us.
yeah, I mean, so the on the when we have a given output data, let me pull in just an example of what that might look like over here. So if I pull in, and this is a GitHub folder that I'm working from, don't worry about looking at this. But here I have three different segments going on. I have all of the rules. It's a bit of a kind of modular monolith, I like to say, because all of the rules that were implemented within Corticon Studio here are completely discrete and maintained independently from what I might be doing with that generated decision service. So from here, I might generate that decision service, subsequently go into start to do some testing. So on the back end, I have a trigger, which is going to isolate out the notable fields from this output. So this is one of the schematic documents that are shared as the background to OpenAI of understanding the nature. And this enables me to do first just querying, natural SQL querying, in order to develop some good representative explanations. But then also, when I start to develop my front end widgets, I can provide the schema of the overall, first of all, the output document object. Secondarily, beside that payload, explanations of all of the rules that have fired, and finally, the metrics themselves. So by feeding this in conjunction with the rule inputs and outputs, we can intertwine and isolate out where specifically logic is produced. So we can then inform at the back end when we're implementing those rules. This is all just as well for training data as well, to understand if something is a late breaking change, we can specify and train within the Corticon AI assistant here. We're hooking into that backend chat by just having an OpenAI key that is aligned with this particular LLM. So this is going to have any of the training data that I might have implemented along the way throughout this.
Okay, that's more specific. Thank you very much. And let's see if we have more questions from other people, not from me. Please ask questions. This is very particular example, and Seth always does this brave things. He puts himself in situation, demonstrating something very openly what they do, and so we have chance to ask.
Yeah, Jacob, I just wanted to pipe in really quickly is that, when you're writing a prompt for any of the large language models to look at a data structure, it's kind of like a pretty standard procedure to explain the schema and the cardinality. And once you do that, it kind of unlocks the power of the kinds of questions you can ask out of that. So we did that a lot in the knowledge worker copilots.
Yes, particularly if there's both on the front end side and within Corticon Studio, as far as the LLM that you're talking with, the extent to which you are going to have a stateful interaction or not is an important consideration. There's a whole lot of background knowledge that would slow things down here, but for perhaps having a particular LLM for just knowing Corticon specifically, knowing every last bit of documentation that is out there for Corticon for the user that might be onboarding, but likewise have different segmented out facets of data in order to understand more rule-specific inputs and outputs and analyses at a broader level, both when implementing the rules and analyzing the outputs. So incorporating the completions API as opposed to the responses API as opposed to the completions API from OpenAI has made this supercharged.
More questions, please. I hate to be the only one who is asking or just dominate this. I noticed that on your GUI you have not just Progress, but Progress Mark Logic. This is a company what Progress acquired a few years ago. So they actually added this OpenAI interface to your product, or is it completely new?
So Mark Logic has been around as long as Corticon, but has always been in the document database world. So structuring unstructured data is their thing. Upon that, just because it's ultimately that's a type of database. Upon that, they've leveraged the UI tooling that is also in-house at Progress to just have more specific widgets in order to perform the types of queries that we might be doing across lots of different documents across a very large data set. So just having those embedded, these embedded widgets also provided with Mark Logic, then we can expose it and expose a chatbot widget, which is just going to provide the UI tooling. And all we need to do is tie the chatbot to OpenAI with an OpenAI key and give it via the RAG endpoints in Mark Logic, the Corticon outputted data and decisioning rationale.
Mm-hmm. I see. And you mentioned unstructured input. You really have examples of, you don't have to show this anymore, but you have examples when you have unstructured input like a PDF document or anything else that you analyze and produce some logical information?
Yes. So one of the things that is quite useful for just baked into the AI assistant is I don't have pre-baked code blocks examples as well, but translating, I mean, if you're going from something programmatically implemented already, then it's going to be far more deterministic than just explaining the rule itself. So generating business rules from existing code blocks is even more valuable oftentimes than just copying the unstructured data, just business rules as business rules. That said, more so on the Mark Logic specific side, their focus is on, say, having master records by incorporating lots of different data formats into one isolated interface. So in the healthcare space, exposing a lot of different documents as FHIR standard compliant, and then we can, in the Corticon world, via a stateless interaction, inform everything we're doing based upon the data format that's being exposed at that endpoint and play within that structured world thereafter.
More questions, anybody? Says you very experienced developer, you created a lot of real decision models using Corticon before. And what is your personal feeling? Tools like OpenAI would be helpful, would be used in real world in, let's say, in 2-3 years, you can see more use of them, or still it just only simple problems could be handled?
It's very hard. So at least from the experience that in my day job and the way in which this Corticon AI assistant has been adopted by our customers thus far, regardless of the ROI that they may or may not be seeing from any of their AI investments, they are investment focused on AI, and so they're kind of leading the new models that we're incorporating into Corticon and building stuff along the way. It's very premature. Like, I think it's easy working at a software vendor where, guess what are the odds a software vendor is focused on leveraging all these LLM tools right now? So it's ingratiated everywhere I look internally, and the adoption is hard to point to the value just yet. So I think to the extent that there can be actually more well-defined returns from non-software vendors remains to be seen. But the ability to which we can at least do things here, like just better document code leveraging these tools, it's quite useful for just modernizing what's already been implemented as well. So there's a lot of value to be found there at the very least.
Okay, good. It's okay. Thank you very much for your great presentation, and
Always
thank you.
keeps me alive.
Okay, bye.